Alright, so now that we took care of unit conversions and rearranging equations, let's move on to trigonometry, which is new to probably most, if not all of you. So trigonometry is something that you should learn in pre-cal, but that's not a required course that you had to take before taking AP Physics. So I'm just going to kind of introduce you to trig. I'm going to start by going through trig as you would in a math class. And teach you all the ways to solve a right-hand triangle. But after all of those examples, I'm actually going to go through how we typically use it in physics and cut out kind of the extra information and teach you really there's like two things that you really do most often in physics. So let's start with just the math trig, and then we'll go into the physics trig, which is probably going to be more important. So physics utilizes a lot of right-angled triangles. Whenever we're talking about projectile motion, or anytime you apply a force at an angle, we're going to talk about it in terms of the X direction and Y direction, so horizontal and vertical. And to do that, that makes a right angle. And so we're really talking about triangles. Now, when you're dealing with right triangles, there's a lot of tools from geometry that we have. One of those being the Pythagorean theorem, which we've been doing since grade school. C squared equals A squared plus B squared. The only important thing is that you always make C be the hypotenuse, and A and B are the other two sides, but it really doesn't matter which one's which. But the most useful version of that formula is where you solve for the hypotenuse, and that's what that would look like. C equals the square root of A squared plus B squared. So you take the two sides, square it, add it, and take the square root. So if we were looking at this triangle, 25 centimeters, 40 centimeters, we take the square root of 25 squared plus 40 squared, and we figure out that the hypotenuse is actually 47.2 centimeters. Okay, remember that the hypotenuse is always distinguishable because it should be the side across from the right angle, so that's one way to tell, and it should also be the longest side of the triangle. So 47.2 makes logical sense. That is a longer value than 40 and 25 centimeters, so we know we're at least on the right track, but that's definitely the right answer here. Okay, so then we get into trig functions. The trig functions are sine, cosine, and tangent. And there's a few general rules. First of all, you can only apply them to right triangles. So if you have an isosceles, don't do trig. The second is that the hypotenuse is the side opposite to the right angle. So exactly what I told you before. You have the hypotenuse, directly across from it, the right angle. And that's always true. Now, if you're missing a side, you're going to use the trig functions directly. So you're going to use the sine, cosine, tangent. But if you're missing an angle, you are going to have to use the inverse of the trig function. So what that looks like, the inverse is this, this list right here on the right-hand side where it's sine to the -1, cosine -1, and tangent -1. And I'm going to explain where those inverse trig functions come from in just a second. The other thing that's important is to know that there's always the adjacent side and the opposite side. And you can see in all of these formulas, you have OPP, that's opposite. You have HYP, that's hypotenuse. And then the cosine formula, you have ADJ, which is adjacent. So let's talk about what that means. So for trig, you have to identify the angle that you want to focus on. So in this triangle, we're looking at the angle in the bottom left-hand corner. And you assign the adjacent and opposite based on that angle. So if that is my angle, the adjacent is the attached side. So for that angle, this side right here is attached to it. And then for the opposite side, you look at that angle, go all the way across, and the opposite side is going to be opposite, right? So for that angle, let me highlight it in a different color. This would be the opposite side. So it's all based on the angle. If we had done the angle up on the top right, it would have been a different adjacent and a different opposite because it's a different orientation in the triangle. Okay, so you always want to think adjacent is attached to the angle or at the angle, and the opposite, just look across the triangle and that would be your opposite side. So you always want to assign opposite and adjacent when doing trig. Okay, let me kind of clean this up. Now let's talk about how to set up the trig function. So we have a saying to remember the formulas. That saying is SOHCAHTOA, and it's just a way to help you remember which trig functions deal with opposite, hypotenuse, and adjacent. So sine is opposite over hypotenuse, and that's where you get SO. Cosine is adjacent over hypotenuse, and that's where you get the CA. And tangent is opposite adjacent, and that's where you get TOA. So it kind of tells you the formula in the little 3-letter word. The middle letter is always the top of the fraction and the last letter is the bottom. So it kind of goes in that order every time. And so I still say it even though I've done trig for a long time. If I'm trying to think, okay, I have the opposite side and hypotenuse, that would be SO. If I have the opposite side and adjacent side, that would be TOA, opposite and adjacent. So you kind of want to use that saying to help guide you. Once you pick out the trig function, let me kind of show you guys. You're going to use this formula every time, right? We're going to use these 3 to set up our formulas, but the inverse formulas right here just come from rearranging if you need to. And what they've done is rearrange for the angle. So that's where you get inverse trig functions from. Let me just use an example with numbers. So let's say we had a triangle, right-hand triangle, and we knew that the angle we wanted is bottom left, just like the image below. Let's say we had a side that was 5 meters, and we knew that this side was 8 meters. Well, let me assign my adjacent and opposite. So for this angle, attached would be this. So this is my adjacent, and then opposite would be over here. And so if I have opposite and adjacent, think about your acronym opposite adjacent. That would be a TOA. So I'm going to be using the tangent. So I'm going to be taking this formula. Now let me go ahead and fill in the values. So we have tangent as our function. The angle, well, the angle is what I don't know. So I'm going to leave that as theta because I can't fill it in. And then it's equal to the opposite. So my opposite I said was 8. You want to make sure you put the right number on top and bottom. So opposite 8. And then my adjacent was 5. Now here's how they got from this original formula to the inverse. The variable I'm missing is theta. I am missing the angle. That's what I want to know. So if I'm missing the angle, that's what I need to isolate on the other side of my equation. Okay, so I really need to move this tangent to the right-hand side. And how do I move tangent to the other side? Well, the opposite of doing tangent is doing the inverse tangent. So I'm going to do the inverse tangent on both sides, and that gets rid of tangent on the left. So if tangent's gone, I only have theta. And then on the right-hand side, now I have tangent inverse. And then I have 8 divided by 5 that I'm going to put in that tangent inverse function. You may be wondering, how am I going to do the sine, cosine, tangent? They are buttons on your calculator. And then if you need to do the inverse, you're going to do Shift and then those functions. And even on the TI-84s, it looks the same way. You have the sine, cosine, tangent, and then you can click shift and then do the functions, and it'll do the inverse. So let me type that in, tan inverse. So I'm going to do shift tangent, and then we're going to do 8 divided by 5. And it looks like my angle is 57.99. So kind of a mess, but 57.99 degrees. That is my angle. And again, these inverse functions are not too bad. It's just rearranging. Okay. Let me do another example with the normal trig functions, because I actually probably should have done that one first, but that's okay. So let's go ahead and make another triangle. And this time we'll do the angle on the top right, just to have something different. This time I am going to let me give the angle to you. So this angle measures, we'll say 40 degrees. So I know my angle this time. Let's say we also knew the hypotenuse. It was 12 meters. But what we want to know is, what is this side over here? What is x? We'll call that side x. So let's figure out what x is as far as the triangle component. So this is my hypotenuse. This is the angle I'm concerned with. We have to figure out, is x opposite or adjacent? And if I can figure out if it's opposite or adjacent, I can figure out the trig function I need to use. So with this angle 40, it looks like x is opposite side of the triangle to the angle. So I do have opposite, and I just said this was a hypotenuse. So then think about your saying, SOHCAHTOA. If you have opposite and hypotenuse, which letters match with which trig function? So we have OH, that should be sine. So we are going to use our sine function, and then you just set up the equation from there. So we're going to say sine. This time I do have the angle, so I'm not going to put theta, I'm going to put 40. Opposite is what I don't know, so I'm going to leave that as x, and then hypotenuse, that's going to be 12. And from there, even though we do have that sine, it works like a regular algebra problem. I need to get x by itself. So to do that, I need to get rid of this 12 and move the 12 over. Well, if it's being divided by 12, I'm going to multiply by 12 on both sides. And so it looks like 12 times sine of 40 equals x. And that's all I need to type in my calculator. And again, it's just a button. So we're going to do 12 times sine of 40. And it looks like x is equal to 7.7 meters. Okay, so it's really not a big deal to use these trig functions. If you have the angle, put the angle value there and do some algebra to solve. If the angle is what's missing, you would have to move the trig function to the right, and that would cause it to be an inverse trig function. Okay, so let's do some math type problems for a little bit, and then we'll switch to what's actually typically used in physics. And there's another caveat. There are multiple ways to solve this problem. So if you use Pythagorean theorem, great. If you end up using the trig functions, also good. You should still get the same answer because they're both based on the same theories. I'm going to try to use mostly trig functions because that's the whole point of doing this lesson, is to teach you trig. But if you do Pythagorean theorem instead, you should get the same answer. Okay, so let's look at example 11. Solve for the missing angle, which is right there, and solve for the y component. Okay, let's go ahead and label our parts of the triangle though. So across from the right-hand angle, or sorry, the right angle is the hypotenuse. And then look at the angle labeled, the angle you're concerned with. If it's attached, this would be the adjacent. So the side is attached to the angle. And then if I look all the way across, that would be my opposite. Okay, so it looks like in this triangle, we do have the hypotenuse, we do have the opposite. And so my immediate thought is, what trig function has opposite and hypotenuse? So let's look back at our list. Well, opposite hypotenuse, that would be a sine function. Okay, so let's go ahead and use that sine function. I have opposite, I have hypotenuse. I'm actually missing the angle. So where the angle's going, I'm going to keep it theta. It's so opposite first. So we're going to do 4.9 divided by the hypotenuse. Since the saying is so, remember that will help you know the order, know which one goes on top and bottom. So we have opposite, then hypotenuse. Okay. Now the missing variable I need that theta. That's what I don't know. And so I need to get that by itself. I need to move the sine over. To move sine to the other side, you're going to take the inverse of sine on both sides. Gets rid of it on the left. And on the right, you now have inverse sine of the same fraction. It doesn't flip it or anything. It just stays the same. Okay, so in your calculator, make sure you type the inverse sign, not the regular sign. So I'm going to do shift sign, 4.9 divided by 7.8. And it looks like the angle is 38.9 degrees. Okay, now that you have this angle, you can actually do trig to get adjacent, which we're still missing, or you can do Pythagorean theorem to get adjacent as well. So like I said, multiple ways to solve this problem. I'm going to use the trig function. And there's so many pathways you can take because you have all the pieces of information. You have hypotenuse, you have opposite, you have adjacent, or adjacent is the only thing you're missing. So if you have the hypotenuse and the opposite side, we could actually use cosine, because we could use the hypotenuse to find the adjacent. Or you could use tangent as well, use the opposite, find the adjacent. And both are valid. We have hypotenuse, we have adjacent. I'll go ahead and do tangent. So I'll choose this function. You could choose cosine if you want. So remember, tangent is TOA. And now I have the angle, so I'm not going to put theta. I'm going to put 38.9 equals, and it's TOA. So opposite, adjacent. 4.9, and I don't know my adjacent. Okay, so we're going to have to do algebra, get x by itself. Hopefully you see the issue here, x is in the bottom. Anytime the variable is in the bottom, that is a problem. I try to teach you guys that trick. Remember, if it's in the bottom, what you can do is swap the places of what's on the left and what's on the bottom of the fraction. So the x would go up, the tan, 38.9, would go down, and just swap the places they're in. So we have x equals 4.9, and then the tan would go where the x used to be. Okay, so let me type that in my calculator. I'm going to do 4.9 divided by tan of 38.9. I get 6.07 meters. So no matter what you did, if you use cosine function, if you use Pythagorean theorem, you should get about 6 for that adjacent side. Okay. Next example, solve for the hypotenuse and the missing angle. Okay, solve for the hypotenuse and the missing angle. Pay attention to the units. So let's look at the units real quick. Okay, 97 centimeters, 1.28 meters. Those don't match. We can't continue until we have uniform units, right? We need everything to be the same. So you can convert centimeters to meters or meters to centimeters. I just find it easier to convert centimeters to meters. Remember that there are 100 centimeters in 1 meter. So you should be dividing by 100. So it should be 0.97 meters. which you can type into your calculator if you need to. But divide by 100, you get 0.97. Okay, now I can find the hypotenuse or the missing angle. I'm not going to be able to use trig to solve the hypotenuse unless I have that angle, but I could do the Pythagorean theorem. So let's go ahead and do that. Let's do the Pythagorean theorem. We're looking for the hypotenuse. Pythagorean theorem is the square root of one side squared plus the other side squared. So let's type that in. 0.97 squared plus 1.28 squared. And you get 1.6 meters. Okay, so we have the hypotenuse. Now we have all three sides. We just need to find the angle. And since we have all three sides, that means you could use any of the trig. You could use sine, you could use cosine or tangent. So let's just do sine. So remember, sine is so. So sine of the angle, which I don't know, so I'm going to put theta, is equal to opposite divided by hypotenuse. So let's figure out our opposite side. We're going to go to the angle, look across opposite, and that's going to be our 0.97. And then the hypotenuse is what we just solved for, the 1.6 meter. Okay, so rearrange. You're looking for the angle. So we need to get the angle by itself. Move sine over. How do you move sine over? You do inverse sine. So on the other side, we'll be doing inverse sine, and you're going to type in 0.97 divided by 1.6 into the fraction. Okay, so remember, inverse is shift sine. So we're doing shift sine, 0.97 divided by 1.6, close your parentheses, and it looks like that angle is 37.3 degrees. You should have gotten the same answer if you did cosine or tangent. If you're not getting that answer, I would recommend checking your settings in your calculator because these formulas do need degrees. And there's a different setting called radians, so make sure you're in degree mode. Just go to the menu and there should be like 3 or 4 lines down. There's a degree radian and make sure the right one's highlighted. Okay, 2 more examples. Y'all can skip around if you're getting the hang of it, but I want to make sure I do every example just so you have plenty of practice. And you can always look up other people on YouTube. I'm not a math teacher, so I know this may not be the best, but there's plenty of resources out there for you guys, and you can always come by tutorials to get any missing gaps you have filled in. Okay, so we have 2 missing sides, x and y, but we do have this angle. So let's go ahead and find our orientation. Here's our hypotenuse. The angle's right here, so remember, attached is adjacent. Go across, that would be your opposite. So x is opposite, y is adjacent. Opposite would be our sine function. Adjacent would be our cosine function. So we're going to do a so and a ca. Let's just start with sine. Sine of the angle, which I do have, is equal to opposite, hypotenuse. Okay, the opposite is what we don't know, so I'm going to put x, but the hypotenuse is 32.3. Get x by itself. Move the 32.3 over by multiplying on both sides. Get rid of that. We're going to do 32.3 sine of 58 equals x. 32.3 sine of 58. And you should get 27.4, and that would be meter. Okay, let's try our y now. So our y is the adjacent side, so we're going to do cosine for the adjacent. Cosine of 58 equals, and it's adjacent hypotenuse. Adjacent is y, hypotenuse is 32.3. We're going to do the same thing as before. Multiply by 32.3 on both sides, get rid of it on the right. And then the final formula, you're going to do 32.3 cosine 58, and that will give you y. So let's type that in. Also, I would encourage you guys to do these on your own and then watch the video just to confirm or deny. Hopefully for these last few, you're doing them before I do them, and then you just play the video to check your answer. Okay, last one, find the value of the marked angle and the hypotenuse. Let's do the angle first. Get your orientation. Across would be opposite. Attached is adjacent. We have opposite, we have adjacent, so let's look at our formulas. Opposite, adjacent, that would be the tangent. Okay, so let's do tangent, TOA. Okay, so we have tangent of the angle, and I don't know the angle, and it's opposite, adjacent. So opposite first, 3.6, adjacent next, 6.2. Here's my variable. I'm looking for theta. Move that tangent over. When tangent goes to the other side, inverse tangent. And then that fraction is caught in a set of parentheses, and that's how you type it into your calculator. So let's do inverse tan. So I'm going to do shift tan 3.6 divided by 6.2. Okay, and you get 30.14 degrees. For the hypotenuse, you could do Pythagorean theorem, or you could also use the angle that we just got. And I do want to keep practicing trig, so I'm going to use the angle. Let's do cosine because we hardly use that one. Let's do a ca. So cosine theta, and I do have the angle, so I'm going to put cosine of 30.14 equals adjacent over hypotenuse, so 6.2 divided by c. Uh-oh, I got a variable in the bottom. I have the variable in the bottom, so I want to go ahead and swap places. Get the variable out of the fraction and up, get the other stuff down. Okay, so it looks like in my calculator, I'm going to do 6.2 divided by cosine of 30.14. And you get 7.17. Okay. Here is a word problem. A cable is attached to a pole that's 10 meters high. So let's go ahead and draw our pole, 10 meters. If the other end is attached to the ground 8 meters from the base. So we have a cable coming out of the pole. Let me make it a different color. And it's attached 8 meters from the base. So 8 meters away from the base. How long is the cable? So it looks like my hypotenuse is what's missing. Well, if that's it, then I can just use the Pythagorean theorem. So if my hypotenuse is missing, we're going to do the square root of 10 squared plus 8 squared. And that gives us 12.8. And that would be it for that example. It didn't talk about an angle. I don't need an angle, so Pythagorean theorem it is. All right, let's look at the next question. You fly a kite 4 feet off the ground, and that's just from your height as a human. So you have the kite in your hand, the string coming out of it. You are 4 feet from the ground. And then it says the string attached to the kite is 300 foot long. There's a 40 mile per hour wind. I don't think that that information is relevant to the problem. I mean, a 40-mile-per-hour wind, you do have to have wind to fly a kite, so I guess it's relevant in the fact that it's just making sure you know the kite is flying, there is wind to kick it off the ground. But 40 miles per hour has nothing to do with the length of the string, the footage off the ground. And it asks how high is the kite from the ground. So the 40-mile-per-hour wind really is not going to affect the problem and is just bonus information. So let's go ahead and cross it out. Do be careful of that because sometimes physics problems do give extra information. So you kind of have to know when to ignore things. And it says the kite forms a 29-degree angle from the ground. So from your horizontal line, which we could actually draw the horizontal at the person's elbow or wherever, their hand. From the horizontal, you have a 29-degree angle. Okay. And it wants to know how high is the kite, and it does say from the ground. So that's why it gave me the 4 foot off the ground, because I do have to take that in consideration. But look, we formed a right triangle right here. So I'm looking, I need to figure out what this length is, but then I also want to add 4 feet to that to account for the extra room between my hands and the ground. So we need to figure out this height using our right triangle that we just made. And then I'm going to add 4 feet to that to get the total height. Okay, so let's figure out this missing side. Focus on that right triangle you just made. We have the hypotenuse. We have this angle, and let's look at what side that is. It is opposite, right? So think about your components. You have opposite, hypotenuse. Which trig function is that? That's sine, right? So sine of the angle equals opposite, which I don't know, over hypotenuse. Get x by itself, we're dividing by 300, so multiply on both sides. So let's do 300 sine of 29. And it looks like that is 145.4 feet. Let's go ahead and add that extra 4 feet, but that's honestly not much compared to what it is. So plus 4 feet would be 149.4. I don't know why I typed that into my calculator, but that kite is 149.4 feet off the ground. Okay, so that's kind of the math-based problems using the trig functions. Yes, we use sine, cosine, and tangent quite a bit in physics, but we really only use it in one specific way. So this was kind of an intro to every possible way you could use it. But let's focus on what it's typically used for in physics. So we just got into the math problems of trig. Let's talk about what could be happening where we would need a right-hand triangle in physics. So let's just take a simple example of I need to push a box across the floor, right? Let's say you're a really tall person trying to push a box across the floor. Well, you're going to have to bend down, and also you're going to be pushing with your arms at an angle, and that's going to cause your whole force, you're pushing with a force, is going to cause it to be at a certain angle from the ground. And so when you get anything at an angle like that, we really want to use our trig functions to our advantage, make it a right-hand triangle, and we can break things down into the x and the y axis. And that's really helpful because thinking of things at an angle is difficult and there's not really formulas for it. Instead, what you really want to do is figure out what is that force in the x direction only along this side of the triangle. How much is he pushing horizontally or across the floor? And then the other component is the y direction. Awesome. He's also pushing in the y direction, and he's pushing down, right? He's pushing down in the y, he's pushing across in the x. And so what we actually want to do is think about what is the y component, what is the x component, and there's where you get your right triangle. Let me just kind of draw the right triangle. So looking at it like it's a right triangle, you can see that the angle we'd focus on is that angle right there. And then you still have your opposite, you have your adjacent, and you have your hypotenuse, and that's where you can use your SOHCAHTOA. And the real goal is figure out what the x component is and what is that y component. So let's just do that real quick. So for the x component, it is adjacent. And let's relate it to that hypotenuse, the original force. So adjacent hypotenuse, that's going to be CA. So you have cosine of the angle. And then instead of adjacent, let's use this fx. And instead of the hypotenuse, let's use the original force. So that's kind of what it would look like in physics. You have the original force, just F. That's the hypotenuse. And then you break it down into the F in the X direction and the F in the Y direction. And that's how you get your sine, cosine, and tangent functions. Let's go ahead and set up for the opposite, the Fy. So if you're looking for the opposite in hypotenuse, if you're looking for opposite in hypotenuse, that would be sine. And opposite goes first. Let's use Fy. And the hypotenuse, which is the original force, would be on bottom. So that's how we're going to use it in physics. You have something happening at an angle, whether that be force, or maybe even it's like kicking a ball at an angle, and you break it down. What is the x? What is the y? What is the horizontal? What is the vertical? And we're using cosine and sine for the most part. Let's look at this example that I have worked out. The variables are a little bit more complicated than the force. It says a ball is kicked at an angle of 34, so angle of 34 from the ground, and travels with an initial velocity. So initial is where that 0 comes into play. It means time 0, so initial means at the beginning. And velocity is where the v comes from. Now, initial velocity is the speed or how fast it's traveling. And we'll get more into that whenever we actually get into our physics lessons. But for now, we're really just trying to look at this right triangle. So we have the initial velocity of 19 meters per second. And there's our hypotenuse. So it's traveling at an angle of 34 degrees with a velocity of 19. What it wants to know is what are the x and the y components, and you'll see that so much in physics. It just wants to know what is the x, so the horizontal, and what is the y, the vertical, x and y. So let's use our trig functions and set up an equation for the x and for the y. Notice it still says v0, v naught, that's what we call it, v naught, and then it has x for the x, and then v naught y. So you got your original, your x, and your y. Let's go ahead and label it as opposite and adjacent. So 34 is the angle we're given. Opposite is going to be your y component. And adjacent is going to be your x component. And that's pretty typical. Opposite is usually y, adjacent is usually x. So it wants us to set up an equation for Vx. Okay, well, we said the Vx was adjacent, and we already have the hypotenuse. So let's think adjacent and hypotenuse. adjacent hypotenuse, that's going to be our cosine. And it gave us the base formula right here. Cosine theta is adjacent divided by hypotenuse. It wants us to plug in our variables. So here's what it did. Cosine theta, theta is theta all the time, but our adjacent for this example, adjacent was actually this V0x, and then your hypotenuse was labeled as V0 or V0. So I went ahead and plug in the variables. And then it also wants you to rearrange the equation, actually get V0 x by itself, because that was the whole point. It wants to know what is the x, what is the y. So we need to have that isolated. Okay, well, if you have cosine theta of V0 x divided by V0, we need to move this to the other side. So let's multiply by V0. And that gets Vx by itself. Okay, so that would be it rearranged. And then you can actually plug in the numbers to get a value. So if we wanted to know what is Vx, we do V0, which is 19, cosine of the angle, which is 34. Okay, and that gives you 15.75. Let's try the same thing, but set it up for y. Okay, so y is the opposite, and we already have our hypotenuse. So opposite hypotenuse, that's going to be our sine. So sine of theta. Opposite goes first. If I look at opposite, I have my Vy. And hypotenuse, just the original V. Okay. Let's go ahead and solve for the Vy. So to solve for the Vy, let me go ahead and rewrite it. We're going to do, to get Vy by itself, we need to move V0 over. So let's multiply. And that's what we end up with. The original side times sine theta. Now, that seemed like a lot, and it is a lot, but in summary, physics will always make you break it down to x and y, horizontal, vertical. And typically, x is related to cosine, and y is related to sine, typically. So you're going to see the same pattern over and over again, using it in the same way. It just takes some practice. So let's try a few physics problems, which we're not going to focus on the physics. We're just going to focus on the angles. So if football is kicked at an angle of 51 degrees from the ground, the starting velocity is 27. Then it says, what was the kicker's horizontal and vertical initial speed? So we're looking at x and y again. So let's mark that, and I'll do it in different colors so we can keep track of it. So let's say we have Vx and Vy. Let's start with Vx. So here's our angle. If our angle is 51 at this point, V0 x would be our adjacent side. And V0 y would be our opposite side, right? Opposite of the angle is across, and adjacent is at the angle attached to it. Okay, so we have it labeled, and this is our hypotenuse. Let's start with V0 x. We need to figure out what that is. Well, V0 x is the adjacent, and we already have the hypotenuse. So adjacent would be a cosine function. Okay, the cosine function, cosine of theta equals adjacent. Let's use our variables though. So adjacent is actually v naught x, v0x, divided by hypotenuse, which is the original v naught. No x or y, just the original v naught. Okay? Let me get this by itself. That's what it's asking me to solve for. If I want that alone, well, I'm dividing by v naught. I'm going to multiply by v naught on both sides. Okay, now that I have it isolated, let's go ahead and plug in our values. So v naught, the original, is 27, cosine, and the angle is 51. So if I type that in, I should get my answer. So let's see how fast it's traveling in the x direction. And it looks like it's traveling 17 meters per second, 16.99. Okay, let's switch over and think about our y. So we already established our v naught y is the opposite side, the vertical. So v naught y is the opposite. We already had the original hypotenuse. Opposite hypotenuse, you're going to be using sine. Okay, so let's set up our sine function. Sine of the angle is equal to opposite. Let me actually put my opposite variable. So opposite in this example is Vy, divided by the hypotenuse, which in this example is V naught. So we always want to use our variables for this problem instead of just saying generic opposite hypotenuse. You want to use your variables. So if it labels it as V naught, you need to be putting that variable there. If it labels it as V naught y, you need to be putting that variable where it goes. All right, so it wants me to solve for the vertical component, that y component. So get that isolated, multiply by V naught, and that gets it isolated. Once you have it isolated and solve for, plug in your numbers. So let's start with V naught, 27, sine, and then my angle is 51. Okay, let's plug that in. 27 times sine of 51, we get 20.98 meters per second. The x and y component are always going to have the same unit as the original. So if the original 27 meters per second, it should match meters per second for both the x and y. Okay. A stunt car driver is trying to break a world record, driving up a ramp with an incline of 42. He hits a ramp with a beginning speed. So beginning is the 0, speed is velocity, and it's 120 miles per hour. By the way, I use a lot of speed because that's the very first thing we'll be going over is velocity. So hopefully this will just make it look not as scary because this already seems scary enough. Okay, so we're traveling up a ramp with a speed or velocity of 120. Then ask, what are the vertical and horizontal? So we're breaking it into our triangle. So let's go ahead and label that. I'll use the same colors as last time. So along our x, V naught x, is our adjacent side. That is a common theme. X is usually adjacent. And then our y, look at your angle. That one's the opposite. Okay, let's solve for x and y. Let's start with V naught x. V naught is adjacent. And we already have the hypotenuse. Guess what? That's another cosine. Adjacent hypotenuse. Set up your formula, cosine. use your variables. So my adjacent is v naught x. My hypotenuse is v naught. It wants you to solve for v naught x, so let's get it by itself. Do y'all see how this is the same thing over and over? Once you get it once, it's not as bad. Okay, now we have v naught x. Let's actually use our values. So start with v naught. That was 120. Cosine, and then our angle is 42. Okay, so let's type that in. 120 cosine 42. 89.2 degrees. Oh, not degrees, geez. The unit for this, I want to match my unit. So if it says miles per hour, this one is also miles per hour. So we're not changing the type of variable. All we're doing is breaking it apart. What was it in the x? What was it in the y? Okay, so there's our x component. We can even fill it in on the triangle if that helps you kind of make your checklist. So we know this now. We have 89.2 miles per hour. We still need to know, what is this y component? So let's go ahead and do that. The y component is opposite, and we have our hypotenuse. So opposite hypotenuse, that's a sine function. So we'll do sine of the angle equals, and remember we're always using our variables, so opposite is Vy, and the hypotenuse is V naught, original. Okay, so same process every time. We need to solve for the y component, so we'll multiply by V naught. And you get V naught sine theta equals V naught y. Okay, so hopefully you see the pattern now. It's always like the original side it gives you times sine theta, or it could also be the original side it gives you cosine theta. Okay, so we're gonna do plug in our numbers. We have 120 sine of 42, and let's type that in. And we got 80.3. Okay. A mover is trying to move boxes across the house more efficiently by pushing the boxes across the floor instead of picking them up. If he applies a force of 54 newtons to the box at an angle of 15 degrees above the horizontal, and we'll talk about what that means in a second, what would the x and y components of that force be, Fx and Fy? So let's draw ourselves a picture. We have the box, and we're trying to push it across the floor. Here's what it means by an angle of 15 degrees above the horizontal. Draw yourself your horizontal line. And it's saying the force is 15 degrees above that. So go and label it like that. Okay, so let's do our x and y components. So we have our x, and this time we're talking about force in the x direction. And then we have our y. And then we also have our original force, and that force that he applies is 54 newtons. And you don't even have to know what that means. Again, we're just looking at the variables and breaking it down using trig. So you have the original force, 54 newtons. You have Fx, horizontal, and Fy, vertical. Okay, let's label it as opposite or adjacent. If 15 degrees, if that angle is given right here, then Fx would be our adjacent, attached. And Fy would be our opposite. Same pattern we keep seeing. So if Fx is dealing with adjacent, that's going to be a cosine. Adjacent is always the cosine. And so you keep seeing these patterns. We're doing the same thing every time. And so it gets easier and easier as you're going along throughout the year. Adjacent is a cosine function. cosine of that angle. And then we have adjacent on top, hypotenuse on bottom. Use your variables. So adjacent, fx, hypotenuse, the original f. Okay, solve for fx, move the f to the other side. Okay, so then you end up with f cosine theta equals fx. Okay, let's solve for fx. Let's plug in our numbers. So the force is 54, cosine, and then the angle is 15. 15. And you get 52.16. Okay, now let's do our y. Y is opposite. Opposite is associated with the sine function. So we're going to do sine, and it's opposite hypotenuse. Use your variables. Opposite, fy, hypotenuse, plane f. Solve for fy. Move f to the other side. And we're done. Let's plug in our numbers. F is 54, sine of 15. 54 sine 15 is 13.98. Okay, so same pattern every time. Usually the x is our adjacent, which is cosine. Our y is usually opposite, which is sine. So try to remember adjacent, cosine, opposite, sine. And that'll help you. And it's always the original arrow times the trig function. So we have f cosine theta, original cosine theta, f sine theta, the original times the sine theta. So that's always the pattern. Okay, Sally decides to take a walk around her block on a nice summer day. She leaves her house and walks east. So remember, never eat sour watermelon. So we have our cardinal directions. So she walks east for about 34 meters. Then she heads north for another 58. It was at that point that Sally decided it was too dang hot for a walk and took the quickest route back to her house. So she went as fast as she could, which would be a direct path along the diagonal. Calculate the length. And when it asks for direction, it's really asking what angle does she start to travel. Okay, so it looks like this time our missing length is the hypotenuse. So this one's a little different. I'm not breaking it down into x and y. It actually gave me x and y, and I'm looking for that hypotenuse. Well, if you're looking for the hypotenuse, the easiest thing to do is Pythagorean theorem. We don't even need the trig function, so I'm just going to do the square root of one side squared plus the other side squared. Let's see what that length is. Square root 58 squared plus 34 squared. And it's 67.23, and it should be in meters because the other values were given in meters. Okay, now it also wants the direction. So when it asks for direction, it's looking for that angle. So to find a missing angle, we're going to have to use a trig function. I'm given, if we're looking at this angle, this is the adjacent side, and the 34 is the opposite. So we're given adjacent and opposite. That's abnormal. Usually we were given the hypotenuse. So let's think adjacent, opposite. That's going to be TOA, opposite, adjacent. So we're actually going to use tan. Tan of the angle, which I do not know. And then it's opposite, adjacent. So let's plug in our numbers. 34, 58. Okay, well, I need to isolate theta, so I need to move tangent over. Remember, when you move a trig function over, it just becomes the inverse. So you have tan inverse of 34 divided by 58. .38. 30.38 degrees. So 30.38 degrees is the angle, but when you're dealing with cardinal directions, it also wants you to describe the direction itself. Is it going north of east, south of west, west of north? So let me teach you how to do that. So what I like to do is draw the arrow kind of on the cardinal map. So pretend this is the origin point. We're going this direction, and we're talking about this specific angle. Now this is only 30 degrees, so it's actually closer to south than west. So 30 degrees, it should be closer to south, but it's swinging slightly towards the west. So in that instance, the primary direction is south, but the secondary direction is west, like it's swinging towards the west. So the way you word that is it is 30.38 degrees towards the west of south, which is kind of bizarre because usually you say southwest or northeast or something like that, but that's how you do it. It's going 30 degrees towards the west of south. Okay, but really the main point of that is get the degrees, which we did, 30.38.